So, measures of central tendency. If we're going to be talking about this, we need to know what that means. When I'm looking at measures of central tendency, that is basically what kind of number can you give me to represent the center of a set of data. So a numerical value for the center, or the middle of our data. With that, the first one, the most common one that you guys are probably used to, is the mean, sometimes called arithmetic mean. That's a lot of times used to represent the middle. We have different variables if we're talking about a sample versus a population. So we know a sample, that's not the whole group, that is a portion of the group. And we use X with a bar over the top to stand for the mean of a sample. If we're talking about the population, they use Greek letters. So this U-looking thing with a really long tail in front, that's called a mu. So if we're talking about the entire group, the population, we'll use mu to represent mean. If we're looking at a sample, we'll use X bar. How do you find a mean?
Add them all together and divide by the total number.
Exactly. Add them all up, divide by the number of points. The shorthand, this sigma just means you add up all the x's, divide by n. Starting in this chapter, we're going to be calculating lots of different things, and so we start having a lot of formulas for those. I'm going to give you guys, go ahead and give it to you today, a packet. It is a very thick packet.
It's just high quality paper.
It is high quality paper.
What was that?
So this is something we will use daily from here on out. So all the different formulas, you don't have to memorize them. You just have to use them. This is your personal copy. I will have copies for every test and quiz that I will give you. So a lot of this we may not get to until the very end of the semester. It's all in one place. So you'll notice it has things kind of broken down by chapter. So chapter 3, the first thing, population mean, and it says mu equals. So if you forget what variable represents population, it's on your formula sheet here. And sample mean, X bar equals. So you don't have to memorize these formulas. They are all given here. You will always have this packet in front of you for anything I ask you to do. So, first example. This is giving us travel times in minutes to work for all 7 employees of a startup web development company. All right, so if it were me, I probably would just write down these numbers for your example. You don't have to write the whole blurb there. So part A, we want the population mean. So population mean is mu. This is the population because it was all 7 employees, the only employees at this company. So we add them all up. And what would I divide by?
7.
it is easy to have a calculation error when you're pushing buttons on the calculator. So the more you can show me, the better. Like, obviously, you could probably do this without writing any work down, but I would encourage you at least write, 174 divided by 7. So if you get the wrong answer, I know, oh, you divided by the right thing, you just added them up wrong or something. Give me as much as you can. And so what do you get?
24.
Okay. And that was in minutes. Okay. Did you guys get that?
Yeah, I forgot to bring my book. I just realized that.
Adio has an extra one, so it's.
I don't know why
Sorry, guys.
I have those big buttons. It's really not my problem.
I was not going.
All right, so B, take a random sample of 3 employees. Compute the sample mean. So give me 3 of these. Let's find the mean for those 3. I just said any 3, so which ones do you want to do?
36. 18.
All even numbers. Wonder how that happened.
Do 5.
All right. Did I get the same mean?
No,
Why?
you didn't have the low and the higher numbers.
Right. So, in general, this is going to be pretty common. If I'm taking a sample, will my sample be exactly the same as the whole population? Almost never. The goal is, if we have a good sample, they would be close to one another. All right. So far, so good? So we know how to find a mean. The next method, another value we could use to find the center of data, this one is actually not on the formula sheet because there's not much to it. It's the median. We use a capital M to represent median. And so that's when you put your data in order from small to large, and you find the one in the middle. So median is the middle as long as our data is in order. From small to large. All right, so from the same data, if I wanted the median, so I have to put them in order, so my smallest is 5, 18, 23, 23. So what's the middle?
23.
23. You have 3 above and 3 below. If you have an even number of points, then what do you do if there's,
Add the middle 2 and divide by 2.
yep, average those middle ones if it doesn't work out, so there's a single value. So our median is 23, capital M for median. All right. Let's say, I'm just going to keep building on this example. So if I add a new employee, and that person has 130 minutes for their commute time, how does this value impact the mean and the median?
Increases them.
Okay. Let's calculate the mean and median. So, my mean, I add all these up. In my 130. I'm going to divide by 8. So my new mean is 38 minutes. You guys agree with that? New median. So for the median, the data has to be in order. Okay, so now I have 8. So to get the middle, I have to do 23 plus 26 and divide by 2. And so what's my median turn out to be?
29 or 24.
Okay. So, how does that compare? What was my original mean? The original mean was 24.86. And that one new person brought the whole thing up to 38. What about the median? My median was 23 and it went up to 24.5. So both increased, but the mean had a larger change. And this is kind of, chose this to illustrate an example. We have multiple ways to find the center of data. And really, the best way kind of depends on the data itself. Okay, if I have all of you take a test, and I want to know how my class did on a test, I could take the average, and that gives me a pretty good estimate. But, if Megan's gone, so I give her a 0 on the test, and then I look at my class average, what's true about that?
It's affected by the 0.
Yeah, the 0 would have brought my whole class average down by quite a bit, right? And so then is the average really telling me how you guys did on the test? No. Looking at this commute time. Okay, one person drives 130 minutes. But look at my average. That brought my average up to 38 minutes. There's only 2 people in the whole company that drive more than 38 minutes. So is this average really reflecting everyone anymore? No. The mean is easily swayed by what we call extreme values. A really high value or a really low value is going to make a big difference on the mean. But the median, I mean, it changed slightly, but it wasn't very significant. With the median, it doesn't matter what your high and low points are, because we're just trying to find the middle. So these extreme values really don't change the median much. So if you have all values fairly close to one another, the mean is a pretty good option. But if you have some really wonky values for whatever reason, then the median is going to be better. We call that resistant. So something is resistant if extreme values do not affect its values substantially. So the median is resistant. The mean is not. We have nice bell-shaped data. Then the median is the middle, the mean is the middle. So the mean and median are the same in perfect bell-shaped data. What do you think happens if our data is skewed right?
Lower than the median.
Okay. So, let's see. I said right, but I pointed left, didn't I? So if it's skewed left, that means I have more low values. So which one is that going to drag down? If you have a bunch of low values, it's going to drag down your mean. If it's skewed right, we have more high values, so what's going to happen to my mean? It's going to increase. So we can even look at the mean and median numerically and tell something about the shape. If they are roughly the same, then we probably have pretty symmetric data. If the mean is less than the median, so the mean is lower, that means we have more low values, so it's probably skewed left. If the mean is higher, that means we have more high values, so it will be skewed right. So sometimes I might ask you about the shape of the data, and you don't have to have an actual bar graph or stem and leaf or anything like that. You could just look at those numbers, the mean and median, and tell me about the data. Now, are they ever probably going to be exactly the same? Unlikely. In perfect data they are, but we know real life data is rarely perfect. So close is good enough, what we're trying to say. The shape. A lot of times they may be just slightly different. I'll give you a second. I know a couple of you are drawing that before I go to the next slide. I'm going to do another example. Everybody's going to need a graphing calculator for the next one. All right, so I've showed you how to find the mean and median by hand. We can use our resources, we can use our graphing calculator to do it as well. Just kind of a general thing, a lot of what we do in here, our calculator can do for us. So a lot of times on a test, I might say, okay, do the first one by hand, and then after that, you can use your calculator to do them. So I'll teach you both ways, but that doesn't mean I will never ask you to do it by hand. I might just ask for one of them by hand. Are we done? Okay. So, the following data represent the asking price of homes for sale in Lincoln, Nebraska. Find the mean and median and use those to give the shape of the distribution. I want to use the calculator to find these. So, on your calculator, we're going to go to Stat, Edit. You probably have data in L1, so remember you can use your up arrow so that you have L1 highlighted. Do Clear, Enter. That will clear everything out. I'm going to put all of this in L1. So all of these numbers go in L1. Alright, so now I want you to push Stat. We're going to go over to Calculate, and number 1 variable statistics. So it's going to ask you what list, so it should be an L1 for everyone. Frequency list, just leave that blank. And then go down to Calculate and hit Enter. And it gives us a list of tons of stuff. So the first question I asked was for the mean. So mean, that's X bar, 123,193.375. So I have my mean. Median. So if you go down as Q1, then the next thing is MED, that is the median. So 127,925. Okay, so mean and median are given for us. What would you predict about the shape of this? Which one's smaller? The mean or the median?
Skewed to the left.
The mean is smaller. So if the mean is less than the median, it's skewed left. Now, is it a massive difference between them? No, so it's probably slightly skewed. It's not a major skew here. All right, are we good with that?
Yes.
The other thing, the mode, that's probably the one we use the least often because it's really not helpful in many situations, but the mode is the most frequent observation. So if we have a repeated value, that the one that shows up the most often is the mode. You don't have to have a mode, so it might be the case that you never had any values repeated. So you might say no mode. Maybe I had two different things that tied for the most frequent, so you could have more than one. So mode is our most frequent observation. It is possible to have none. We don't have any shorthand for mode. We just write the word. So we're going to do just a couple examples and then I am done for today. Mean, median, and mode. That wasn't too bad for a day, was it?
What's tomorrow? Range?
Range, standard deviation. Yep. Look back at the example we've been doing with the travel times. What was the mode for that set of 7 points? 23, because we had 2 people that traveled 23 minutes.
I'm really sorry.
Why?
I just made that really loud chant.
All right, let's look at this one. A set of data includes the values 11, 15, blank, 24, 29, 31. If the median is 20.5, can we find the missing value?
Yeah.
All right. So we're all algebra people. Everybody in here has had algebra. So we could think of it that way. The median, how do we get the median? Has to be in increasing order, which it is. So then we are finding the middle of our set of data. So we have 6 points. That means the middle is the combination of those. So if I call this x for a minute, that means x plus 24 divided by 2 was 20.5. So to solve for x, we can multiply by 2. Subtract the 24. So my missing value was 70. The last one, we're going to look at an example out of the book. So if you didn't bring your book, scoot in next to someone who does.
This is in my defense, I never did go down that hallway.
Oh, it makes it better.
I stayed on this side of the school the entire time, so can't be mad at me.
I was very angry, but I feel better now. It's all good.
I'm glad I could convince you.
All right, so number 32. Mr. Zuro finds the mean height of all 14 students in his statistics class to be 68 inches. So the number of students in the class, that's 14. The mean is 68.0. Just as he finishes explaining how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students? So I don't have the original 14 values. How am I going to find the new mean?
68 times 14.
Think about how we get the mean. We add up all of the values, and we got something. We divided it by 14, and that equaled 68, right? So if I'm trying to find x here, multiply over your 14. So 952, that's the sum of the 14 students. So to find my new mean, we have to take the sum of those first 14 plus the sum of the 15th student, which was 65, and now we divide by 15. And so the mean is now 67.8 inches. Does that seem reasonable? Her height was below average, so it should drop the average a little bit when we brought her in. All right. Any questions over anything I've done today? So homework, we're going to use the book for a couple days this section. We'll use the book tomorrow as well.